Okay, Harry has two five-sided spinners, fair five-sided spinners, and he's going to spin each one, complete the probability tree diagram. So he's got, for this one, 2 red, so that's 2 out of 5. And he's got 1, 2, 3 green, which is 3 out of 5. And then for the second spinner, he has 1, 2, 3, 4 reds. So that's 4 out of 5 and 1 green. And then 4 reds and 1 green. And that's how you complete that. Now, the question is, work out the probability that at least one of the spinners will land on green. So that means that it is this one lands on red and then green, it's green and then red, and you have to remember how they ask the question. So at least one, so you can have the one that has both the greens. Now, I'm quite lazy, so the way I would do this is I'd go 1 for everything minus the possibility of red followed by red. So that would be 2 over 5 times 4 over 5. And that equals 6 over, no, it equals 8 over 25. I can't do 2 times that. So what is 1 minus 8 over 25? It is 17, so it's 25 over 25. 25 minus 8 is 17 over 25, and that's how you do the second part of that to get all the marks you need. You could, if you were planning on being a little less lazy than me, do this one, which is 2/5 times 1/5, plus this one, which is 4/5 times 3/5, the other way around. And then you could add 3/5 plus 1/5. And what you'll get is 3, 12, 4, that's 12, 15, 16, 17. Anyway, my way is easier. So, number 16, this is a circle theorem question. And with circle theorem questions, always give a reason. Emilio, my godson, is very good at doing everything in his head. And so it just means he never shows any working. And they reckon he went down a full grade by never putting his working in. And it's like not impressive, even though, it's good to be good at mental maths. L, P, L, M, N, and P are points on a circle. So that's a cyclic quadrilateral. Angle MNP is 58. So find the size of MLP. So that's what we're looking for. Now, the thing that we need to remember is that the, what's that called? The angle, hang on. So the angle at the center is double that at the circumference. And angles around a point are 360. So that's the reasoning I'm giving for this. So that means 58 times 2 is 116. And if we are going to, and then you could just do that, because we're doing the opposite, if you see what I mean. So the opposite of 116 was 360 minus 116, which is 200. Hang on, I'm actually going to do this on this. You can't see this, but that is fine. It's 244. So if that's there, then that means that, oh, no, we can use another thing. Actually, so we know that this and this, so MNP plus MLP adds up to 180. Yeah, I literally could have just done that. So that would be, we can check that. So 180 minus 58 equals 122. And so that was angles opposite one another in a cyclic quadrilateral. Add to 180. And then find the size of the reflex angle MOP. So reflex means bigger than 180. So it's the other side of the MOP, so it's 244, which we found already. I went at that in a very weird way, which I often do with these things. But anyway, we got 4 marks for that. Now, a metal block has a mass of 5 kilograms, correct to the nearest 50 grams. So whenever you see that, do this. 5,000 grams, 5,050 grams, 4,950 grams. So find the midpoints, and we'll find the upper bound is going to be 5025, and the lower bound is going to be 4975. There you go. The block has a volume of, so this is mass, and volume equals 1.84 times 10 to the power negative 3, which is 0.00184. 1, 2, 3, yeah. To 3 significant figures. Work out R. Now that's to 3 significant figures, so that means that it's, let's go for its upper bound and lower bound as well. So that would mean its next significant figure would be 0.00185, and its lower one is 0.00183, so 0.00185 and 0.00185. So this is its lower bound and upper bound. Work out the upper bound for the density of the block and give your answer in kilograms per metre cubed, correct to 1 decimal place, and show you're working clearly. So upper bound, let's remember that density equals mass over volume. So to get the upper bound, we need big mass. So we need, I almost kind of want to put this in another colour. So to get the upper bound, we need the high version of mass, which is that one. Do I need this in kilograms? I think I do. Hang on, kilograms per metre cubed. So yeah, I need it in that. So on the top, I've got to have 5.025 kilograms. And on the bottom, I need, if you remember, the smaller one will give us the answer. So it's going to be 0.001835. Okay, so the density equals that divided by that, which is 5.025 divided by 0.001835. And it gives me, oh, it's quite big. So the density is, oh, it is metal. So density equals, and what do I need it to 1 decimal place? 2738.4 kilograms per metre cubed. And that's it.